Sounds like a pain in the butt, but did you know that in prehistoric times, humans actually used wood to wipe their behinds? In fact, we still do. Only now, the wood is ground, pressed, bleached, and rolled into what we call toilet paper. So how are hundreds of billions of rolls made every year? The journey begins in vast forests, where giant steel machines can bring down dozens of towering trees in just a few minutes. From there, the logs are sent straight to massive industrial mills, going through dozens of precise steps before becoming those soft, feather-light rolls the entire world depends on. And today, Agriculture Insight takes you inside that fascinating process to uncover how humans turn rough tree trunks into a small white symbol of comfort and civilization. When it comes to toilet paper, there's probably nothing more fascinating, just like the thoughts running through your head when you suddenly run out. More than 2,000 years ago, before toilet paper existed, humans used all kinds of things to wipe. Stones, dry branches, corn cobs, even seashells. The ancient Greeks used small ceramic discs, while the Romans had a stick with a sponge on the end, washed in salty water and shared by everyone in public baths. But countless ways to wipe. Humans have always been incredibly inventive when it comes to staying clean. It wasn't until the 6th century, in China, that toilet paper was first recorded, and it took over 1,000 more years before it became a household essential around the world. Today, the world produces more than 300 billion rolls of toilet paper every year, and this massive industry generates over $60 billion in global revenue. In the United States alone, the average person uses about 100 rolls per year, most of which are produced domestically. Familiar names like Charmin, Cottonelle, Scott, and Quilted Northern dominate the market, turning toilet paper into a true multi-billion-dollar business. And if you were at the supermarket, how would you choose your toilet paper? By brand, by the claims printed on the package, or simply by which roll feels right at first glance? And now, let me take you to the southeastern United States, where the subtropical climate and year-round rainfall have nurtured vast eucalyptus forests, meticulously planned and cultivated specifically for the paper industry. Each tree takes up to 20 years to mature. When the trunk reaches a diameter of 10 to 12 inches, with moisture below 60% and optimal cellulose content, it's ready for harvest. When the harvest season arrives, the forest comes alive. Massive harvester-forwarder machines, each weighing nearly 18 tons, move into action. First, hydraulic arms clamp the tree trunk tightly, while a chainsaw blade slices cleanly through the base in just seconds. The trunk is then lifted and fed through an automatic delimbing unit, where rotating rollers strip off branches and bark. Next, laser sensors determine the precise length and send data to the machine's control system. The log is automatically cut into even sections, roughly 2 meters long, the ideal size for transport and later pulp processing. The entire sequence takes only a few dozen seconds, requiring almost no human touch. Yet every move is tracked by GPS to ensure cutting stays within designated zones and avoids disturbing the forest floor or young roots. Even the machine's tracks are engineered to distribute weight evenly, preventing soil compaction and allowing the forest to recover quickly after harvesting. Most of the wood used for toilet paper is considered low-grade timber, crooked trunks, young cores, or blemished logs unfit for furniture making. Yet this very wood has the perfect balance of fibers and lignin for pulping. On average, 1 ton of eucalyptus can yield about 700 kilograms of paper pulp, and on an industrial scale, a single plantation like this can supply toilet paper for millions of people each year, all without touching a single natural forest. As the first trees fall, the next star of the forest takes the stage, the forwarder, a timber hauler capable of carrying up to 14 tons of logs in a single load. In other words, with just about 70 trips, more than 1,000 tree trunks can be transported to the collection site. Despite its massive, almost beast-like frame, the forwarder moves with surprising grace. With a hydraulic arm and a mechanical grapple that can rotate a full circle, it grips, lifts, and stacks bundles of logs weighing hundreds of pounds with precision, a mesmerizing mechanical dance in the heart of the forest. From here, the journey to transform those rough wooden trunks into soft white sheets of paper begins, as the green forest connects seamlessly to the mill through a transport network stretching for miles. When the timber trucks arrive, the journey begins anew in a very different way. Here, the logs enter the first stage of the paper-making industry. Thousands of tree trunks are unloaded onto vast yards spanning hundreds of hectares, where they are sorted, measured, and stacked into towering rows, forming walls of wood that mark the true beginning of their transformation. Every sheet of paper begins with pulp, but before it becomes pulp, each tree trunk must first be chipped into wood fragments, a process that seems simple but serves as the first true test of precision. Inside an industrial chipper weighing several tons, steel blades spinning at up to 700 revolutions per minute slice the logs into perfectly uniform wood chips, each measuring only about 2 to 3 centimeters in size. Here, uniformity is everything. If the chips are too large, the chemicals won't penetrate evenly. Too small, and the cellulose fibers will break apart. The entire operation is monitored by optical sensors, transforming what once seemed like a brute mechanical step into a fine display of technological precision. After that, the clean wood chips are pumped into a high-pressure digester, where a mixture of alkaline chemicals and heat breaks down the lignin, the natural glue that binds cellulose fibers together. Over roughly 3 hours of cooking, the lignin dissolves, leaving behind an ivory-white suspension of fibers, a thin, milky liquid that is, in fact, pulp. From a single batch of 25 tons of wood chips, the mill produces about 15 tons of high-quality pulp. The leftover black liquor, rich in dissolved lignin, is recovered and burned to generate energy for the mill itself, completing a closed-loop cycle of material and energy. The final step before this humble pulp begins its transformation into toilet paper. However, compared to virgin pulp, which consumes vast amounts of energy, water, and forest resources, recycled paper offers a far more sustainable path for the toilet paper industry. It can cut energy use by up to 50% and save 70% of water for every finished sheet produced. Yet, turning old paper into new material is no simple journey either. Recycled paper is collected from all kinds of places: offices, stores, printing houses, but not every sheet can make it back into the production cycle. At the mill, an automated sorting system takes on a task that seems simple, but demands incredible precision, separating paper from plastic, cardboard, metal, and debris. Using near-infrared sensors, the system scans each piece of paper to identify its material composition. And in a fraction of a second, bursts of compressed air blow away unwanted particles from the conveyor belt. Thanks to this technology, a single production line can handle up to 400 tons of recycled paper per day, creating a clean, consistent source of raw material, the foundation for everything that follows. Recycled paper, once sorted, is fed into an industrial shredding machine. Inside, counter-rotating steel blades pull the paper inward and tear it apart through continuous cutting, producing thousands of small uniform pieces just a few centimeters wide. The speed and spacing of the blades are automatically adjusted according to the paper's thickness and type. The entire process is enclosed, ensuring the paper is loosened and separated layer by layer, ready for the next stage of pulping and de-inking. After being shredded, the paper is sent to the processing area, where it enters a massive industrial washing system that runs through 14 continuous treatment stages. Here, layers of cellulose fibers are released from their original structure, ground into a fine pulp, and pass through multiple filtration screens to remove even the tiniest impurities. Next, the pulp moves into centrifugal cleaning chambers, spinning at extremely high speeds to separate heavier particles such as sand, metal fragments, or small pieces of wood. Though this process demands a significant amount of energy, it's still considered far greener than producing virgin pulp from wood, with each ton of recycled paper saving dozens of trees and thousands of liters of water. Even after cleaning, the pulp still carries the traces of its past, ink. To remove it, the pulp is mixed with a special soapy solution. As the mixture is stirred, countless tiny bubbles rise to the surface, lifting microscopic ink particles that cling to the foam. The dark froth is then skimmed away, leaving behind a cleaner, ivory-colored pulp beneath. Finally, the pulp undergoes a mild bleaching process and is diluted with water, forming a smooth, milky suspension, the purified pulp, ready to be reborn as paper once again. At the heart of this process stand massive machines over 120 meters long, running day and night, carrying out 4 remarkable stages of transformation that turn nothing more than water and cellulose fibers into paper. The pulp is diluted and pumped onto a continuously moving mesh belt known as the fourdrinier wire. As the slurry spreads evenly across the surface, water drains through the mesh, leaving behind a tightly interwoven network of cellulose fibers, the very first rough form of paper. At this stage, both the shape and strength of the sheet are determined. Even the slightest deviation here will leave its mark throughout the paper's entire lifespan, much like the foundation of a building. At this point, the paper sheet still contains dozens of times its weight in water. To remove this excess, it passes through a series of press rollers, each weighing several tons and operating under extreme pressure. As the sheet moves through, it is tightly compressed, forcing out moisture while strengthening the bonds between cellulose fibers. Continuing its journey, the wet paper sheet enters a system of massive heated drying cylinders, or long drying tunnels, stretching dozens of meters, where high temperatures evaporate the remaining moisture. Under the intense heat, the cellulose fibers contract and bond more tightly, forming a continuous sheet of dry paper that races forward at more than a mile per minute. This stage consumes the most energy, but it is also what determines the paper's whiteness, strength, and stability. Once it leaves the dryer, the paper still carries wrinkles and ripples caused by heat expansion and contraction. It then passes through a series of calendar rolls, where heat and pressure are precisely adjusted to smooth the surface, create a gentle sheen, and ensure uniform thickness. The result is a soft, even ribbon of paper, winding gracefully around the Yankee dryer drum, the final step before it's cut, embossed, and packaged. All of this happens in just 7 seconds, from a watery slurry to fully formed sheets of paper, light as air, yet born from hundreds of tons of force and thousands of sensors. After all that, the long sheets of paper stretching hundreds of meters are sent to the winding and cutting section, where the final shaping and packaging take place, turning them into finished products. Massive rewinding machines, each over 80 meters long, can process up to 500,000 rolls per day. The paper is then embossed with delicate micropatterns, creating its signature dotted texture, a design that not only softens the surface, but also enhances thickness and absorbency. Once completed, the rolls are cut, wrapped, and packaged, ready to enter a global distribution network spanning more than 190 countries, where every day, billions of people begin and end their routines with this seemingly humble product. Every journey has its beginning. For flax, it starts in humble fields, where the plants are harvested through a blend of modern machinery and human hands. Every July, when flax flowers have faded and the stems turn yellow at the base while the tops remain pale green, it marks the perfect time to harvest, ensuring the fibers are long, soft, and durable. Across the flax fields of Belgium, France, and the Netherlands, specialized harvesting machines roll into action, kicking off a process that is both precise and visually striking. Unlike crops like wheat or corn, which can be cut at the stem, flax must be pulled out by the roots to preserve the full fiber length. To do this, the industry uses specially designed flax harvesters, equipped with rotating clamps and root-lifting conveyor systems. As the machines move forward, two large rotary clamps continuously grip the rows of flax and pull them upward. The 1-meter-long stems are kept perfectly straight as they move onto conveyors running along the length of the machine. There, the stalks are laid side by side into neat, even rows and gently placed back onto the field. Within minutes, golden-green ribbons of flax are spread across the ground with precision, ready for natural drying. Compared to traditional manual harvesting, modern flax harvesters increase efficiency by 5 to 6 times, while ensuring that the fibers remain straight, consistent, and unbroken. An essential requirement for the high-end linen industry, where every centimeter of fiber is closely monitored. During the process, flax seeds are also separated. The flower heads containing the seeds are suctioned through a system of tubes transferred into a separation chamber and then deposited into bins attached to the machine. These seeds are later used for fertilizer, animal feed, or industrial recycling, while the flax stalks remain in the field to dry. This drying phase allows the natural pectin to break down, making it easier to separate the fibers during the next stage of processing. After 2 to 4 weeks, the flax stalks have reached the ideal level of dryness. At this stage, flax baling machines take over to complete the harvest. These machines are specially designed to handle the light, long, and delicate nature of dried flax stems. At the front, 2 spiral-shaped pickup arms continuously gather and guide the rows of dried flax toward the center of the machine, feeding them into the central compression system. Inside the chamber, rollers and belts rotate in unison, generating strong pressure to tightly compress the flax into large cylindrical bales, each with a diameter of up to 1.4 meters and an average weight of 250 to 300 kilograms. Once a bale reaches its optimal size, the locking mechanism automatically releases, pushing the bale out the rear of the machine and leaving behind a line of flax wheels, neatly spread across the field. On average, a single machine can produce 25 to 30 flax bales per hour, depending on field conditions and material density. After finishing the job, the machines leave the field while the flax bales are collected using grab loaders and loaded onto specialized trucks for transport. These modern harvesters feature high-capacity tanks that reduce the need for frequent unloading, optimizing efficiency for large-scale operations. Their smart design ensures high yields while preserving the quality of the seeds for the next stage of processing. And when the harvest is complete, both the stalks and the seeds make their way to processing facilities, where they continue the story of this extraordinary plant, from fine linen fabric to a rich source of essential nutrients. Now, let's dive into the process of making the oil hailed as the omega-3 king of the food world, flaxseed oil. As soon as the flax seeds arrive at the processing facility, they are sent through a cleaning line. Here, the seeds are screened, dehulled, and separated from dust, debris, and empty shells. Next, they are passed through a grinding system to break the outer husk, making the oil extraction process smoother and more efficient. Flaxseed oil must be extracted using a cold press method, with the temperature strictly maintained below 40 degrees Celsius (140 degrees Fahrenheit) to preserve the full omega-3 content. This is the key factor that gives flaxseed oil its superior nutritional value compared to other vegetable oils. After pressing, the crude oil is further filtered to remove fine particles and impurities before being bottled in dark glass containers to reduce oxidation. This is crucial because flaxseed oil is highly sensitive to light and air. Improper storage can cause it to lose nutrients and develop off flavors. The final product is a pale golden oil with a light nutty aroma and a mild, smooth taste, hailed as one of the healthiest edible oils for heart and brain health. Now we return to the most anticipated part, the journey of transforming coarse, dry flax stalks into premium linen fabric, the very material that has defined the prestige of the global sustainable textile industry. Upon arrival at the factory, the dry flax bales are delivered to the receiving area. Here, workers conduct an initial assessment of moisture content, fiber length, and remove any bales that fail to meet quality standards before proceeding to the next stage. Once the inspection is complete, the bales are sent into the preliminary separation system, where they are unwrapped and loosened. A conveyor belt feeds the flax bundles into the spreading machine, where spiral gears and high-speed rollers work together to continuously tease apart, untangle, and evenly distribute the dry stalks into flat layers. This mechanism breaks up the naturally compact structure of the bundled flax, creating ideal conditions for the fiber separation stages that follow. At the same time, larger impurities such as roots and woody fragments are filtered out right from the start. Once the flax bales have been spread out, they move on to the fiber opening machine, which breaks up the tightly bound structure, allowing the flax fibers to loosen and separate more freely. Inside the machine, fiber clumps are fluffed up by high-speed rotating shafts and powerful airflows, transforming them into a light cloud-like layer. This airy fiber layer then falls onto a vibrating conveyor belt, which simultaneously transports and evenly sifts the fibers downward, filtering out fine dust and enhancing the loft and uniformity of the material. At the end of the conveyor, a set of shaping rollers, typically 2 to 3 slow-turning cylinders with grooves or soft bristles, gently compresses and aligns the flax fibers in a single direction. This process creates a smooth, parallel fiber sheet with consistent thickness and spreads it evenly across the delivery slats, making it easy to roll into compact, sturdy fiber rolls. After being rolled up, the raw flax fibers are stored and later transported to weaving mills, the next stop on their journey to becoming finished linen fabric. Upon arrival at the weaving mill, the raw flax fiber rolls are sent to the combing area, where the fiber bundles are further disentangled and refined. Here, the combing machine features multiple rotating rollers embedded with fine metal pins or brushes. As the fibers pass through, these pins stretch, straighten, and remove short or excess fibers, leaving behind only the long, smooth, and uniform strands, essential for producing high-quality yarn. The result is a series of smooth, parallel fiber bundles known as slivers. The slivers are then fed into a parallel drawing machine, where they are combined and stretched repeatedly to ensure consistent length and density. During this process, the fibers pass through successive sets of rollers, with each pair rotating faster than the previous one. This controlled stretching makes the slivers finer without breaking them. After 2 to 3 rounds of drawing, the fibers reach the desired fineness and uniformity needed for the actual spinning phase. This next step is crucial for transforming the delicate slivers into true flax yarn. Inside the spinning machine, each sliver is passed through a system of rollers and spindles that simultaneously stretch and twist the fibers. The level of twist is carefully adjusted depending on the desired yarn type. Tighter twists for fine, high-end fabrics, and looser twists for thicker, splied, more robust textiles. Finally, the finished yarn is wound onto bobbins or spools, ready for weaving. Depending on the product design, the flax yarn may be dyed before weaving. In the dyeing room, yarn spools are placed into rotary dyeing vats, where dye solutions are circulated and thoroughly absorbed into each fiber. This process requires precise control of temperature, pH, and timing to ensure even, long-lasting color that won't fade after washing. Once the flax yarn is fully prepared, it moves on to the weaving machines, where the actual construction of fabric begins. Warp threads are aligned parallel and stretched tightly across the loom, while weft threads are inserted back and forth using a shuttle, needle, or airjet system, depending on the type of loom. With each weave, the loom lifts and lowers the warp threads in a programmed sequence to form patterns, while the reed beats the weft into place, producing a strong, cohesive fabric. Modern weaving speeds can reach 500 to 800 picks per minute, generating dozens of meters of fabric every hour. After weaving, the linen fabric is inspected for defects, then rolled and sent to finishing stages such as washing, softening, drying, cutting, pressing, and packaging, ready for the market. You may have never seen a tobacco plant with your own eyes, but every year, the world still harvests over 6 million tons of tobacco leaves, fueling an industry worth nearly $900 billion. China currently leads in production with more than 2.6 million tons annually, but the most famous tobacco brand in the world comes from the United States, Marlboro, which accounts for up to 14% of global consumption. And you, what's your #1 brand? And every great story has a beginning. For this smoky muse, it all starts in the sun-drenched tobacco fields, where warm summer breezes signal the first whispers of harvest. From around July to September each year, the tobacco fields enter harvest season. Harvesting requires great precision, relying on both experience and traditional principles. Specialized machines move slowly through the head-high rows of plants. Beneath them, a system of sharp rotating blades precisely cuts the mature leaves close to the ground. Immediately afterward, soft conveyors receive and lift the leaves, preserving their shape and moisture while minimizing tearing or bruising. Leaves must be picked when they are not too wet to prevent bruising, yet not too dry, which makes them brittle. The ideal temperature is between 20 to 25 degrees Celsius, and harvesting typically takes place between 5 and 9 a.m., when the leaves are still supple and retain a healthy sheen. The leaves are delivered directly into a large ventilated container at the rear, designed to prevent moisture buildup and premature fermentation. Once full, an automatic unloading system transfers the leaves to a detachable bin or a specialized truck moving alongside. On average, a single machine can harvest about 5 tons of fresh leaves per day, 8 to 10 times more efficient than manual labor, while also reducing risks and improving efficiency across the entire production chain. At some cigar tobacco farms, machines are used to harvest the entire plant. These devices cut the stalk at the base, Gently lift the full row and automatically hang the plants onto integrated curing racks, ready for drying. Notably, keeping the stalk intact allows sap to continue distributing into the leaves during drying, making them softer, more elastic, and rich in natural oils, crucial qualities for producing smooth, flexible, and glossy wrappers for premium cigars. In Cuba, Nicaragua, and the Dominican Republic, the birthplaces of hand-rolled cigars, the tradition of harvesting by hand is still carefully preserved, serving as a tribute to the leaves that will become the soul of premium cigars. Unlike the mechanical precision of machines, manual harvesting follows a slow, deliberate rhythm rich with craftsmanship. Skilled workers closely examine each leaf, using its color, sheen, and elasticity to judge the perfect stage of ripeness. After harvesting, the leaves are bundled into small groups and placed in woven baskets or breathable racks to maintain their shape. Though labor-intensive and slower, this meticulous process is what gives handmade cigars their unique value. Why a single premium cigar can fetch hundreds of dollars, while a pack of machine-made cigarettes costs just a few. From here, the leaves begin to diverge, some destined to become artisanal cigars, others entering the industrial pipeline of mass-market tobacco. Let's begin with the remarkable story behind every cigar. Not just something to smoke, but a product born from time, technique, and traditional craftsmanship. Immediately after being harvested, tobacco leaves enter the curing stage, the first and one of the most critical steps in cigar production. The leaves are hung in curing barns or sheds, where temperature, humidity, and airflow are tightly controlled. Depending on the leaf variety and desired flavor profile, different methods may be used. Sun curing, air curing, smoke curing, or heat curing. This process usually takes several weeks and requires great precision, as even small deviations can significantly impact leaf quality and the final cigar flavor. After curing, the properly dried tobacco leaves move on to fermentation, an essential stage for refining flavor and stabilizing leaf structure. The leaves are stacked into large piles called pilones, where heat naturally builds up through biological decomposition. During this phase, unwanted compounds such as excess nicotine and ammonia are removed, while natural aromas are enhanced. Workers regularly turn the piles to control temperature and humidity, and lightly moisten the leaves to maintain optimal conditions. Once fermentation is complete, the tobacco leaves are carefully sorted based on size, color, softness, and flexibility. Each cigar requires 3 types of leaves: the wrapper, outer layer; the binder, middle layer; and the filler, inner core. The wrapper is the outermost leaf, directly impacting the cigar's appearance and flavor. The binder holds the filler together, providing structure, while the filler, the heart of the cigar, is made up of several smaller leaves blended according to a specific recipe. This filler blend is what gives each cigar its unique flavor profile and signature character. For premium cigars like those from Cuba or the Dominican Republic, hand rolling remains the gold standard. Skilled artisans carefully select the appropriate filler leaves, arrange them according to a specific blend, then roll them tightly with a binder and finish with a smooth wrapper. Each cigar is shaped, the head is twisted, then it's placed into a mold for pressing and undergoes thorough inspection before storage and packaging. While each artisan can roll only a few dozen to a few hundred cigars per day, their precision and craftsmanship result in a level of quality that's unmistakably superior. Although the cigars are already complete in appearance, they still require time to rest. This post-roll aging stage lasts from 2 weeks to 3 months, allowing the tobacco leaves to blend and the flavors to stabilize. During this period, the compounds in the filler, binder, and wrapper gradually harmonize, creating a balanced aroma, taste, and burn. As a result, the cigars reach their ideal state before being packaged and shipped. Meanwhile, in large-scale factories, automated cigar rolling machines are used to boost productivity and standardize the product. First, tobacco leaves are fed into the machine and cut to pre-programmed specifications. Once the filler, binder, and wrapper layers are precisely arranged, a system of rollers tightly wraps them into the shape of a finished cigar. The head of the cigar is then neatly twisted by the machine to ensure uniform size and appearance. Next, the cigars pass through a preliminary inspection line before moving on to the next stage. Specialized equipment is used to assess the roundness, firmness, and tightness of the cigar's head, as well as the condition of the wrapper surface. Any cigar showing defects, such as loose rolling, torn wrappers, or incorrect dimensions, will be rejected or redirected to a separate category for further handling. After that, each cigar is carefully wrapped in a thin layer of nylon to protect its outer structure, maintain optimal humidity, and ensure complete hygiene. This wrapping also helps shield the cigar from environmental factors during transportation and storage, preparing it for the final packaging stage. And now, let's explore the cigarette manufacturing factories, where each cigarette is produced through a closed-loop process that is both rapid and highly precise. Unlike the artisanal craftsmanship of hand-rolled cigars, cigarette production is highly industrialized, driven by extensive automation and advanced technology. Unlike cigars, which require each leaf to be hung individually, tobacco leaves used for cigarettes are typically stacked in large cages or mesh containers, then placed into sealed curing chambers with automated temperature and humidity controls. These high-capacity systems operate continuously and can cure several tons of leaves each day. The drying process removes moisture and stabilizes the leaf structure, preparing them for further processing. Once the leaves reach the desired moisture level, they are compressed into tightly packed bales for easy storage and transport to the main processing plant. At the factory, the tightly packed bales of tobacco leaves are unpacked and fed into a modern cutting system. Here, the leaves are shredded into fine, uniformly sized strands, making them easier to roll into paper and ensuring a consistent, even burn in every cigarette. These shredded tobacco strands are then moved into a blending process that follows a proprietary formula unique to each brand. In addition to the primary tobacco material, the blend may include several additives such as flavor enhancers, humectants, and aromatic agents, designed to smooth the draw, adjust the scent, and enhance the overall smoking experience. The entire process is strictly monitored and controlled to ensure uniformity and maintain the final product's quality standards. Once the tobacco filler is ready, the automated production line feeds it into specialized rolling paper tubes, ensuring an even burn and controlled smoke output. The processes of rolling, cutting, attaching the filter, and shaping the cigarette are all fully automated, producing thousands of cigarettes per minute with high precision. Once the finished cigarettes meet quality standards, they are transferred to a fully automated packaging line, a highly precise and tightly controlled process. Every 20 cigarettes are neatly aligned and inserted into a specially designed cardboard box. These boxes are built to withstand transportation while also clearly displaying the brand's colors and imagery. Next, each pack is wrapped in a layer of foil or thin aluminum film to preserve the aroma, block moisture, and shield the contents from environmental factors. This is followed by an outer shrink-wrap plastic layer, which enhances durability and gives the final product a sleek, polished look by the time it reaches the consumer. Thanks to advanced automation, modern factories can produce hundreds of thousands to millions of cigarette packs per day with near-perfect consistency. And that is the meticulous journey, from delicate leaves swaying under the sun and wind to the iconic product of a multi-billion-dollar industry. In June, canola blooms into a radiant sea of gold, drawing in swarms of honeybees. Smart farmers place beehives around their fields, not only to boost pollination but also to collect sweet honey, a double gift from nature. And when the golden fields turn a pale brown, harvest season begins. Depending on weather conditions and crop uniformity, farmers use one of two main methods: direct combining or swathing, cutting first, harvesting later. In Canada, the swathing method is commonly used to ensure crop quality and reduce the risk of seed loss. This process involves cutting the canola plants and laying them in neat rows, called windrows, directly on the ground. Swather machines are equipped with sharp blades, moving conveyors, and a rear roller that gently presses the plants down to protect them from strong winds and allow the seeds to ripen evenly. Once the windrowed plants have dried to an optimal moisture level, a combine harvester fitted with a specialized header moves in to complete the harvest. The machine lifts each row and gently threshes the tiny black canola seeds to minimize loss. The remaining stems and leaves are discharged behind the machine and left in the field, helping retain soil moisture and returning nutrients to the soil. From above, the windrows resemble golden waves resting quietly, waiting to be swept into the rhythm of the harvest. But not every region has to wait. In drier, less windy regions, like the western United States or Western Australia, farmers often prefer the direct combining method, which is simpler, faster, and more efficient. When the canola seeds have turned fully brown and dried evenly on the plant, a combine harvester equipped with a straight-cut header moves through the field, harvesting the entire plant in a single pass. The canola stalks are cut at the stem, then threshed, sifted, and the seeds sorted right inside the machine. A massive combine harvester can process up to 30 tons of canola seeds per hour, roughly 150 times the output of manual labor over the same time. Whether harvested through swathing or direct combining, every journey ends the same way. The seeds are collected in the harvester's storage tank. Once full, the canola is unloaded directly into waiting trucks lined along the edge of the field. And with that, the harvest comes to an end, sending every tiny black seed on its way to the oil mill, ready to begin its transformation into the golden essence that ends up in kitchens around the world. As soon as the trucks carrying thousands of tons of canola seeds arrive at the factory gates, a strict quality control process is triggered. Each truck is weighed using a precise electronic system, and a sample from every batch of seeds is collected and sent to the laboratory for analysis. There, specialists test for key indicators such as moisture content, cleanliness, and most importantly, the potential oil yield. Only batches with a minimum oil content of 40% or higher are considered acceptable for processing. After passing the initial quality inspection, the canola seeds are poured into intake hoppers and transferred directly into massive storage silos, each capable of holding between 5,000 and 10,000 tons. The entire storage system is tightly controlled for temperature and humidity to prevent mold growth and maintain optimal conditions in preparation for the next stage of processing. From the silos, the canola seeds are transported by conveyor belts into the primary cleaning system. Here, high-capacity vibrating screens work in tandem with powerful air suction systems to remove impurities such as leaves, straw, stones, soil, and any shriveled or damaged seeds. To preserve oil quality and prevent moisture-related issues, the seeds are dry cleaned only. No water is used. This ensures maximum efficiency while minimizing the risk of mold, spoilage, or oil loss during the extraction process. Once cleaning is complete, the canola seeds move on to the crushing and flaking system, an essential step in the journey of transforming raw seeds into refined drops of health. Here, pairs of heavy-duty rotating metal rollers apply intense pressure to crack the seed coats and flatten the kernels into thin, even flakes. This flaking process breaks down the cellular structure, allowing the oil inside to be more easily extracted in the next stages. The flakes are then fed into a sealed heating chamber, where they are gradually warmed to temperatures between 85 and 100 degrees Celsius for several minutes using a modern steam heating system. This heating process lowers the viscosity of the oil, making it easier to extract during pressing. It also deactivates harmful enzymes while preserving valuable nutrients, thanks to precise temperature control throughout the chamber. Now comes the most critical stage of all: oil pressing, the golden key in the journey of transforming canola seeds into pure kitchen gold. Unlike cold pressing methods used for premium oils like olive, virgin coconut, or avocado oil, where temperatures are strictly controlled to preserve natural flavors and nutrients, canola oil is primarily produced through high-capacity hot pressing. Massive screw press machines begin running continuously, generating immense pressure to extract oil from the flakes prepared earlier. Thanks to their industrial-scale performance, each press can handle between 1,000 and 1,500 tons of seeds per day, the equivalent workload of over 500 manual laborers. However, even with this intense force, mechanical pressing typically extracts only around 65 to 70% of the oil content from the seeds. To maximize oil yield, the process doesn't stop at mechanical pressing. The leftover material, known as canola cake, still contains residual oil. To extract it, the cake is fed into a solvent extraction system. Here, hexane, a petroleum-derived solvent, is used to dissolve the remaining oil. The resulting mixture is then passed through a vacuum evaporation system that separates the hexane from the oil without affecting its quality. Most manufacturers assert that over 99% of the hexane is completely removed during refining, ensuring the oil is safe according to industry standards. However, trace residues, even in tiny amounts, have raised concerns among some consumers about potential long-term buildup in the body. Additionally, if not properly managed, hexane evaporation can raise environmental concerns. After the oil has been fully extracted, the remaining meal is dried and compressed into pellets or cakes, which are then used as a protein-rich animal feed for livestock and poultry. The oil collected from both mechanical pressing and solvent extraction is blended and directed into an advanced filtration system. Here, the oil passes through multiple layers of specialized materials designed to capture even the finest particles, microscopic debris, dust, and residues invisible to the naked eye, ensuring a perfectly clean and crystal clear oil stream. After filtration, the oil undergoes a deep refining phase, which includes degumming, neutralizing free fatty acids, bleaching, and deodorizing. This thorough process not only removes all unwanted components, but also enhances the oil's stability, extends shelf life, and ensures the final product meets strict food safety and hygiene standards. Finished canola oil is not only low in saturated fat, but also rich in omega-3, helping to better balance the ratio of omega-3 to omega-6 in a typical diet. Meanwhile, sunflower oil, though refined through a similar process and known for its high vitamin E content, contains significantly more omega-6 and should therefore be consumed mindfully to maintain a healthy nutritional balance. Before being bottled, canola oil must go through a strict quality control process. Technicians check for purity, color, and odor, and ensure that no residual hexane or impurities remain, making sure that only the highest quality oil reaches consumers. After passing inspection, the oil is pumped into a fully automated packaging area. Here, transparent PET plastic bottles are created on-site from small preforms. These preforms are heated until soft, then shaped using high-pressure air in a blow molding machine, resulting in lightweight, durable bottles that are as clear as glass. Once molded and sterilized, each bottle moves to the filling station. Under a high-speed system, canola oil is dispensed at an astonishing pace, filling hundreds of bottles every minute. Immediately afterward, robotic arms tightly seal the caps to ensure an airtight, secure closure that protects the product's quality. Next, labels are printed and applied with precision using modern sensor-based technology.